Now there are a few very convenient properties of logarithms that we'll use when we see certain things happening. One of those we saw up above when we were talking about log base b of 1. Log base b of 1 is equal to 0 all the time. So if we take the logarithm of 1, it doesn't matter what base we have for b, it's always going to be equal to 0. Kind of in the same fashion, log base b of b itself is just equal to 1. And this is because b to the first power is the same thing as itself. b to the first power is equal to b. And then there's some simplification, sort of cancellation things that happen with logarithms. So for instance, if you have log base b of b raised to the x power, because the base is the same for the log as what's on the inside of the logarithm, basically what will happen is the whole log will cancel out, and all that'll be left over is the power x. So log base b of b is just equal to x. That's one property of logarithms. Also, if you have b raised to the log base b of x, now the b is down below, and then above that we have another log base b. So since these are the same numbers, we're going to get these two things canceling out, and all you'll be left with is just the x. So b raised to the log base b of x is just equal to x. So in example 4, we're going to just go ahead and say what each of these logarithms are equal to based off of some of those simplification properties for logarithms. First off, log base 7 of 7. Well, that's just equal to 1. Because 7 and 7 are the same and there's nothing else going on here, so log is just equal to 1. Same for log base e of e. It's also equal to just 1. Log base 5 of 1, that's a situation where the logarithm is equal to 0. So anytime we have 1 inside the log and take the log of 1, we're always going to get 0. Now here's where the cancellation properties can show up, something like log base 4 of 4 to the 5th power. Since the base are the same, here the 4 and the 4, those are the same number, this whole thing will cancel, leaving us with just the 5. Log base 4 of 4 to the 5th is just equal to 5. So what would we say log base 7 of 7 to the 8th power would be equal to? Indeed, same idea from up above. These will go away, leaving us with just 8. And then we might see situations where we had like x raised to the log base x of 17. So since this is an x and it's above another base of x, those two will cross out, leaving us with this just the 17. Okay, so now we have two kind of logarithms that are often abbreviated, the common log and the natural log. So the common log is log base 10. So most often log base 10 is just written as simply log. So log base 10 of x is the same as just log of x. So if we see log without any base below it, it's just meant to be an understood 10, base 10. Now the natural log is the log base e. So another name for e is the natural base. So when we have a log base e, we get something called the natural log. And so log base e, as I mentioned at the beginning of the video, is abbreviated ln, which is kind of backwards from what we would think in L for natural log, but this came from past abbreviations, so we carry forward it and call it the ln. So when you see ln, it's an understood log base e. So let's look at a few examples of just these kind of logarithms. Let's start out with log of 10,000. So when we see log of 10,000, keep in mind that what we're looking at is log base 10. Log base 10 of 10,000, which we can treat just like any other log we've done before. If you want to convert it into exponential form, call it equal to x, swap around these two things, make it look like 10 raised to the x power is equal to 10,000. So what power of x would you have to raise 10 to get to 10,000? Indeed, that would be 10 to the fourth power is 10,000. So the fourth power is the exponent, and what we say is that log of 10,000 is equal to 4. So here's another thing that we see with log of 10 to the 2x power. So as before, you can take log, put it as log base 10, understood base 10 there. So it's log base 10 of 10 to the 2x. But as we talked about before, these two things will completely cancel out with each other, since they're the same number inside and for the log as well. So that's just going to be equal to the 2x. And this also happens with e to the natural log 3x minus 1. So keep in mind again that ln is log base e. So if I put the log base e here, we have e raised to the log base e. Those two will cancel out completely, and this will just be simply 3x minus 1. We also see this happening with the base 10. If we go 10 raised to the log of the cube root of x. So when you see the log, you can change this over to 10 raised to the log base 10 of the cube root of x, which means that those two will go away, cancel out, and you're going to be left with just the cube root x. And then one last example, let's take a look at the natural log of 1 over e to the 7th power. So when we see the natural log, let's go ahead and convert the ln over to log base e. Log base e of 1 over e to the 7th. To make this work, what I'm also going to do here is change this over to e to the negative 7 power, since that's a negative exponent in the denominator. And when I do that, these two things will cancel out completely, and all we're left with is just negative 7. So that's one way of using the cancellation between ln and e in order to simplify.